Okay, we're looking for H here. So what's our process to start finding H? Okay, we split the 38 in 2 to get 19 feet is the run. Remember, the 7 here means that this is a 7-12 slope. So it's a 7 rise for 12 run. The 19 is now our run. We cross multiply and divide 7 times 19 divided by 12. Which gives us our rise, 11.0833333. Now, that's in feet. We want it to the nearest 16th of an inch. So with our calculator, how do we do that conversion? Well, minus 11, that's our whole feet. Very good. So it's 11 feet. We take what's left, we multiply it by 12 to turn it back into inches, and we get exactly 1 inch. I didn't even have to worry about the 16th of an inch. It came out to exactly 11 foot 1 inch. Now, here's the trick. I want to now find the length of this top chord. I need that 11 foot 1 inch back into a decimal foot so that I can use it. Well, a couple things I can do. First of all, this is going to be a squared plus b squared equals c squared, right? To get that? Review from last semester. So here's what I'm going to do. I'm going to do second square root. 19 squared, that part's easy. Plus, how do I do the 11 foot 1 inch? I do 11 plus 1/12. Put it in parentheses, and I square that. Equals 21.996369, blah, blah, blah. 21.9964 feet. Now let's convert that into feet, inches, and 16ths. How many whole feet? 21. So what do I do here? Subtract 21. And then what? That divide. Multiply by 12. So 11.956. So it's 11 inches. Now what? Subtract the 11 first. Then times 16. It's 15.3, which is between 15 and 16, closest to 15 sixteenths. So it's 21 feet, 11 and 15 sixteenths inches. So almost 22 feet. What do you think? Loads of fun? Better than a sharp stick in the eye?
Depends on the day.
Let's say after a 6% trade discount, you pay $799 for materials. Find the list price. In other words, find what the full price was before your discount. I'm going to give you a couple minutes to work. Okay, so here, after a 6% discount, that means we paid 94%. So the $799 is the 94%. We are looking for the full price, 100%. Cross multiply and divide here, we get 850. Any question of homework and stuff from last class, from Tuesday? To continue with our ratio and proportion, I realize you guys are not in masonry, you are in woods, but you need to understand a little bit about the masonry side of it. And we did the estimating the volume of foundations and stuff last semester. Well, I talked just a touch about mortar mixing today, because it's a great application of ratios. If you look at the front of the packet I gave you, there's a table about 2/3 of the way down the page where it lists the different types of mortar. So we've got type M, S, N, and O. Now mortar has 4 main ingredients. We have cement, Portland cement, which is the stuff that sticks everything together, holds everything together. We have lime, which kind of works with the Portland cement. It's kind of sticky, but it gives it a little more volume, a little cheaper than Portland. Not as sticky, but it does the job. It fills it up. Sand, which is kind of what gives the mortar its stature, its volume. It's the Portland bonding the sand together that makes it fill up space and gives it volume. And then water. What we're going to look at here is the ratio of cement, to Portland, to lime, sand. Now it's the ratio of Portland to lime that's really what determines what type of mortar it is. But we'll talk about the sand more later on. For type M mortar, it is 1 part cement to 1/4 part lime. In other words, a 4-to-1 ratio of Portland to lime, of cement to lime. And then 3 parts sand. For type S is a 2-to-1 ratio, so it's 1 part cement to 1/2 parts lime and a 4.5 parts of sand. Type N is 1-to-1, 1 part cement to 1 part lime to 6 parts sand. And type O is a 1-to-2, so 1 part cement to 2 parts lime to 9 parts of sand. So now what we've got here is just the different ratios. The next section there says quantity per cubic foot. What this is for every cubic foot of mortar you have, how much of each ingredient do you have? So like for type M, 1 cubic foot of mortar has 0.29 parts cement, 0.07 parts lime, and 0.87 cubic feet of sand. If you add that all up, that adds up to be more than 1, doesn't it? Why? No, it's not because it expands. It's because the particulate size. Think about it. Sand, we think of it as being small particles, but it's actually almost like grains, like salt. Well, between those grains of sand, there's space for other stuff to go in. So the lime and the mortar actually goes into those spaces between the grains of sand. So even though a bucket might be full of sand, you can still fit some mortar and lime in it because it fits in between little spaces. It's a little bit more graphic if you think of gravel. Like you got large rocks with sand in it. And you have the large rocks and the bucket may look full, but you can still add sand to it because it fits in between the bigger rocks. Same type of concept here. So each of those has that type of ratio set, or those divisions set up. And you can see even the 1-to-4 isn't perfect here. That's partly because of round off. This is technically like 0.286, and this is technically 0.073 something if you wanted to get down to the 100th of a cubic foot. So anyway, how are we going to work with these? Well, let's flip over to the next page, top of the next page. On the top of the next page, it says, if I want to make 36, so problem number 1, we're doing a type N mortar, we want to make 36 cubic feet of mortar. How many bags of Portland cement do we need? So it's going to be 36 times what? For type N, the Portland is 0.16, right? Everybody see where I got that? So 36 times 0.16 is 5.76 cubic feet of Portland. Now, Portland usually comes in either 1/2 cubic foot bags or 1 cubic foot bags. If you're working on a construction site and you're ordering it from a supplier rather than just going to like Menards and buying it, you'll get it in a 1 cubic foot bag. A lot of what you would buy off the shelf at Menards is actually a 1/2 cubic foot bag. So now the lime comes next. The lime is 36 times, also 0.16. So 5.76 cubic feet of lime. Now sand, there's just a little bit of a caveat there. What do you see that's different on the sand label there? It says cubic yards. So the sand, we're going to do a 36 cubic feet times 0.96 is the number for the sand. Not divided by 3, you got 34.56, that's cubic feet. To turn cubic feet into cubic yards, you divide by 27. In other words, 3 by 3 by 3. So 1.28 cubic yards of sand. So that part's not so bad, right? So you notice actually for A and B, it actually says bags of Portland and bags of lime. That's a bag is a cubic foot. So I'm going to assume you guys can do 2 through 5 there. I'm going to move down to the next table. Actually, you know what? I'm going to have you guys do number 2 on your own right now quick. I'm going to give you a minute to do that. Just to get just have one on your... Let's try and go through number 2 quick. So number 2 is type S. 99 cubic feet. So I'm just going to write down the numbers here. Type S, 0.21, 0.10, and 0.94. So for type S, Portland cement is 99 times 0.21, which is 20.79, 20.8, works for me. The 99 times 0.10 is 9.9 cubic feet for lime. Then for sand, 99 times 0.94, then divided by 27 gives us 3.45 cubic yards of sand. What do you think? What's that? Not bad? Okay. Next table then, we move down there to the bottom of the page, page 92. This is actually giving us the number of bricks it'll take per 100 feet. 100 square feet. So we usually in construction we talk about a square. A square is 10 feet by 10 feet. So this is bricks per square depending on the size of brick. Then it's also talking about the amount of mortar per thousands of bricks. So let's do this. I want to build a wall. That is 8 feet high and 48 feet long. So how many square feet is that? 384 square feet. So 384 square feet of wall. I am going to use a standard 4 by 2 2/3 by 8 inch brick. That's actually the brick that are in the wall here. Those are 4 by 2 2/3 by 8 inch. Now, how many of those, if I look at the table, that's actually the top row, 4 2 2/3 by 8. What does it say for bricks per 100 square feet? 675 bricks per 100 square feet. I don't have 100 square feet. I have 384 square feet, don't I? So to find my number of bricks, I cross multiply and divide. So 384 times 675 divided by 100. I'm going to have 2,592. That is bricks. So it takes 2,592 brick to do this. Next, I want to know how many cubic feet of mortar. I'm going to assume that this is going to be a 3/8 inch mortar joints. 3/8 inch is pretty standard. Half inch is, actually, if you've ever seen a wall that's done with half inch, it actually looks like big mortar joints. So I'm looking at 3/8 inch mortar joints. What does it say for cubic feet of mortar per 1,000 bricks? 8.1 cubic feet per 1,000 brick. And I have 2,592 brick. So, cross multiply and divide it. Cross multiply and divide. So 2,592 times 8.1 divided by 1,000. We get 20.9952 cubic feet. In other words, 21 cubic feet, right? Of mortar. Now, commonly, there will be an addition to this for some sort of waste. Looks like they're saying about 25% for mortar needed. So what we do for mortars, for 25%, you do 25% would be 1.25. Where'd the 1.25 come from? 100 plus 25% is 125. So I'm finding 125% of 21. So 125% of 21 would be 26.25, right? So what do you think? Not horrible? Not entirely? Not like the funnest thing in the world? Are you kidding me?
No Disneyland.
Oh, come on.
You want to be a princess now?
Disneyland, no Disney World.
Yeah, because Bambi's not dead.
Okay, so here's what we're going to do. I want to build a basement. It's 32 feet by 48 feet. 8-foot high walls. So the first thing I want you to do for me is figure out how many square feet is that. Easiest way to find our square feet is just to find the perimeter of the basement, which is how much? 32 plus 48 plus 32 plus 48 is 160 feet. And this is basically a lateral area. Take that perimeter, 160 feet, times the height of 8 feet, which is 1,280 square feet. Does that look right? Yeah?
Yeah.
So that is my area of my wall. I am going to use standard modular. Eight by 4 by 12 inch block. So I want to know, number one, how many blocks? I should say how many brick, because this will be brick. And I am going to add to this, it doesn't say, I'm going to say add 10% for waste on the brick here. So we have 1,280, right? If we look up the 6,412, what does it give us in the table? 300 brick for 100 square feet, right? So on page 92 is the bottom line on that table, the 8,412. So for 1,280 square feet, we get 3,840 brick. That's how many brick is estimated. Now we're going to multiply that by, how are you going to find 10% waste? Times 1.10. So 4,224. That's how many brick I would order for that. For mortar, I go back to this original number before the estimate of waste. For mortar, what does it say for mortar if it's a 3/8 inch joint? 25.9, right? That's 25.9 per what? Per 1,000 brick. So I want to know how much for 3,840 brick. So 25.9 times 2,840 divided by 1,000. 99.456 cubic feet times, we're doing the 25% for that, so times 1.25. Why did they figure so much waste? 1.25 seems like a lot of waste. Well, because you got spillage off the sides, but also your brick have cavities in them, and you end up dropping mortar down the cavities of the brick and stuff like that. You're also required to fill every so many cavities. That's part of that's actually figured into the table, but there's loss when you do stuff like that. So 124.5 cubic feet of mortar. So how much Portland? Did I say what type of brick I was going to use? I did not yet. Let's say I tell you that we are going to use a type S mortar. So we're type S mortar. Portland is 124.3 square cubic feet times 0.21. Gives us 26.1 cubic feet of mortar. How about lime? Well, 124.3 times for lime, it's 0.10. So 12.4 cubic feet of lime. And finally, sand. Cubic yards of sand. 124.3 times 0.94 is 116.84. Of course, we have to divide by 27 to make that cubic yards. 4.3 is 3, it looks like. Cubic yards of sand. What do you think? Easy stuff?
As long as you got the paper, man.
Okay. So, your assignment for the next about 35 minutes is to do this packet. Give you some time to work.